Hello everyone, welcome back to the YouTube channel of Developers and Codescribe. Today we are here to solve a problem from recent contest of Codeforces, that is min-max sort, and the contest was educational Codeforces round 142. So let's see what the problem is asking to us, then we will see how to approach it. So we are given that a permutation P of length n, and what is a permutation? That is a permutation of length n is an array of length n in which each integer from 1 to n occurs exactly once. You can perform the following operation of n number of times on this permutation. The operation is choose two different elements x and y and erase them from the permutation. Then insert the minimum of xy into the permutation in such a way that it becomes the first element, and insert the maximum of x and y into the permutation in such a way that it becomes the last element. Means what we will do, that if 2 5 1 3 7 8 and 4 and 6 this is given to us, then if we select 5 and 3, then what we will do, remove them from the given permutation, then that will be like 2 1 6 7 8 4. Then take minimum of this, that is 3, insert that in first of the permutation, and take maximum of this, that is 5, insert that in the last of the permutation. So that is the operation which we will do. Then for example, if P is 1542, then we want to apply, that is simple, understand that how we perform the operation. Then our task is to calculate the minimum number of operations described above to sort the permutation P in ascending order. So if you want to see the test cases, then in this first test case, that is given to us 1 5 4 2 3. And if you want to make the in sorted order, then we will select first what we can select. I think if we select 2 and 4, then that will be 2 1 5 3 and 4. Okay, then if you select 1 and 5, that will be 1 2 3 4 and 5. That is sorted, so we have to perform two operations here. Okay, then if you see, this is already sorted, so this is 0. In this 2 1 4 3 is given to us. Then if we select 1 and 4, then 2 3 is already, and 1 minimum is 1 and maximum is 4. So this is our sorted permutation, so we have to perform one operation. Then in this 5 2 4 1 6 3 is given to us. Then first of all, if we select what we can select, that if we select 3 and 4, then that will be 5 2 1 6, minimum is 3, maximum is 4. Then if we select 2 and 5, then this will be 3 1 6 4, minimum is 2 and max. Okay, let me write it here, that is 2 3 1 6 4 and maximum is 5. Okay, and then if we select 1 and 6, so this will be 1 2 3 4 5 6. So we have to perform one operation here, then second operation here, then third operation here. So we have to perform three operations. So answer for this is 3. So now let's see how to approach it. So if you want to make some example like 5 2 1 3 6 4, what will be the sorted format of it? Okay, so first of all, let us make it sorted in by applying these operations. Then if I select first of all 3 and 4, okay, then what will be the remaining permutation? That will be 5 2 1 6, minimum is 3, maximum is 4. Then if I select 2 and 5, then this will be 3 1 6 4, minimum is 2, maximum is 5. Then if I select 1 and 6, then minimum is 1, maximum is 6, and remaining permutation is 2 3 4 and 5. So that is our permutation, so we have to perform three operations here. Okay, then let's see how to make such type of pairs. Then we can see that this is our given permutation, that is 5 2 1 3 6 4, and our sorted permutation is 1 2 3 4 5 6. So can you find that if we make pair like 1 and 6, 2 and 5, 1 and 6, 2 and 5, and 3 and 4, if we make pair of these elements, then only we can get our solution. Why? Because we all know that if 1 is our first element, then 6 will be our last element. If 2 is our second first element, then 5 will be our second last element. And if 3 is our third element, then 4 will be our third last element. So we have to make pair like this. Like if n is 10 is given to us, then how we will make pair? That will be 1 10, 2 9, 3 7, 4 6, okay, 3 8, 4 7, and 5 6. Okay, so we can see that if n is 10, then our operation will be 5. So in final our answer will be n by 2. What if n is odd? Like if n is 9 given to us, then this will be 1 2 3 4 5 6 7 8 and 9. So 1 will pair with 9, 2 with 8, 3 with 7, 4 with 6, and 5 is alone. So how much operation we have to perform? 4 operation. So if 9 is given to us, then operation will be 4. So answer is same, 1 by 2. Float value of 9 by 2 will be 4. Okay, now just tell me that if like 2 3 4 1 6 and 5, this is given to us, then according to our observation, first of all we will make a pair like 3 and 4, then we will make a pair of 2 and 5, then we will make a pair of 1 and 6. If you make 3 and 4 pair, that will be 2 1 6 5. This is deleted from the permutation, and minimum of this 3, maximum of this 4. Okay, this operation is done. Then if you select 2 and 5, 2 and 5, so 3 1 6 4, minimum is 2, maximum is 5. Then if you select 1 and 6, then 1 and 6, so 2 3 4 5, minimum is 1, maximum is 6. So we have to perform 3 operation. Now let's see again this permutation, that is 2 3 4 1 6 5, and just tell me that if I directly select 1 and 6 from this permutation, 1 and 6 from this permutation, then this will be 2 3 4 5, minimum is 1 and maximum is 6. Yeah, that is already sorted. So in one operation we get our answer. Then why we need to perform all 3 operation? So how to get this condition? Then we can see that what we will do, like if we random permutation like this given to us, then we will make this sorted according to this. In our initial approach, what we are doing, that we will select first 3 and 4, then 2 and 5, then 1 and 6. Means we are going to make sorted from 3 to 4 first, then from 2 to 5, then from 1 to 6. Okay, what if 3 to 4 is already not sorted, like this is given to us? Then first of all we have to make this in sorted order. We have to select 3 and 4 first. This will be like this. Then we again have to select 2 and 5. This will make our solution. But what if already 3 and 4 is sorted, like 3 and 4 is already sorted, and 2 and 5 is randomly written here? Then if we skip the step of 3 and 4, it directly jump to 2 and 5. Then select 2 and 5, that will be 2 3 4 and 5. So that is giving us a sorted order. So what I want to say, that this is our order to check this, perform the operation. So first of all check that if 3 and 4 is already sorted, like 3 and 4 is given to us in the given array, there can be some element here, but or just point that the index of 3 is less than 4. If that is, then we check for 2 and 5, that if 2 3 4 and 5, this is already sorted, there can be some element, but I just want to see that is 2 3 4 and 5, index of 2 is less than index of 3, is less than index of 4, is less than index of 5. If that is, then we check for 1 and 6. If 1 2 3 4 and 5 is 6 is given to us, I just want to check that if index of 1 is less than index of 2, is less than index of 3, till the index of 6. If that is, then we will skip this operation. So first of all our operation was n by 2. If that is satisfied, then we will reduce our operation. If this is also satisfied, then we will reduce our operation, and if this is also, then we will again reduce our operation. So let's see it in another example, like n is 8, then okay, 2, 3, 4, 5, 6 and 7, 8, 1. Okay, what will be the pairs? That will be 1, 8, 2, 7, 3, 4, 5, 6. Okay, so this will be 1, 2, 3, 4, 5, 6, 7, 8. So this is the pairs. Then if we check first of all for 4 and 5, because we will start from this, then we will go to this. If we check first of all for 4 and 5, index of 4 and index of 5, is this less than this? First of all, our operation was n by 2, that is 8 by 2, that is 4. So if that is satisfied, we will reduce our operation. So this is now 3. Okay, then we will check for 3 and 6. That is 3, 4, 5, 6. This is given to us. I just want to check that index of 3 is less than index of 4, and index of 5 is less than index of 6, because we already checked that index of 4 is less than index of 5, so we don't need to check again this. We only need to check only these two conditions. If that is, then we again will reduce our operation. So in this example, index of 3 is less than 4, yeah, there it is. Index of 5 is less than 6, yeah, there it is. So we can reduce our operation, and then this will be now 2. Then we will check for 3 and 6 is checked, then we will check for 2 and 7. So index of 2 is less than index of 3. What we want to check, that 2, 3, 4, 5, 6 and 7. Is this given to us? Then we have already checked for this, for this, for this. We only check for index of 2 is less than index of 3, as well as index of 6 is less than index of 7. If that is, then we again reduce our operation. So check for this. Is index of 2 is less than index of 3? Index of 2 is less than index of 3. Yeah, that is. Is index of 6 is less than index of 7? Index of 7 is here, index of 6 is here, so that is not. So we cannot perform an operation here. So final value of operation will be 2. So check for this. What is the permutation? That is 2, 7, 3, 8, 4, 1, 5, 6. 3, 8, 4. Okay, so 3, 8, 4, 1, 5, 6. My answer is we have to perform 2 operation here. So what will be that operation? That first of all we will select 2 and 7. Then we will select 1 and 8. If I select 2 and 7, then remove this. Remaining permutation will be 3, 8, 4, 1, 5, 6. Minimum is 2. Insert it in the start of the permutation. Maximum is 7. Insert it in the last of the permutation. Then from 1 and 8, 2, 3, 4, 5, 6, 7. Minimum is 1. Maximum is 8. So yeah, we are getting our sorted permutation in operation 2. So now what I will do, that if n is 8, then first of all we will check for 3 and 4. So how to get these? Okay, let me check again it, that where is that? Yeah, here, this is here. So if n is 8, then what are the pairs? 1, 2, 3, 4, 5, 6, 7, 8. So if n is 8 given to us, then first of all we will check for 4 and 5. Okay, so what happened was this. Okay, then first of all we will check for 4 and 5, then we will check for 3 and 6, then we will check for 2 and 7, then we will check for 1 and 8. And on any person, if we get false, then we will terminate from this loop. Like I will check for a while loop. Okay, so if n is 8, then we will check from 4 to 5. So can I say that if whatever n is given to us, we will check from n by 2 to n plus 2 by 2, because if n is 8, then n by 2 8 will be 4, and n plus 2 by 2 will be 5. So yeah, I can say that if whatever n is given to us, then our first element will be n by 2 and second element will be n plus 2 by 2. So I am pointing this from mid 1. Okay, let me make it here, that n by 2 n plus 2 by 2. So I am pointing this from mid 1, and this is our mid 2. Index of this is int1, index of this is int2. And you can see that if we are checking for like this type of condition, 3 4 5 6, 3 4 5 6, then what I have to check that index of 3 should be less than index of 4, and index of 5 should be less than index of 6. So initially this was our mid 1 and this was our mid 2. Index of this will be int1 and index of this will be int2. Okay, then first of all I will check that is int1 is int1 is less than int2. If that is, then what I will do, I will decrease my mid 1 with minus 1 and increase our mid 2 with plus 1. Okay, then update our int1 with index of mid 1 and int2 with index of mid 2. Okay, so what will be the int1, that because initially mid 1 was 4 and mid 2 was 5, I have decreased it with 1, so that will be 3, and increase it with 1, that is 5 6. Okay, so int1 is holding over index of 3 and int2 is holding over index of 6. Okay, so if I want to check this, then I have to also store the previous index of this 4 and 6. So for that I am making another two variable, that is prev1 and prev2, that is holding the, before applying this operation, the index of int1, like prev1 is holding the index of mid 1 and this is index of mid 2. After calculating this, then we will perform this option, then we will reduce our mid 1 with minus 1 and mid 2 with plus 1. Then our int1 will be updated with index of new mid 1 and int2 is index of new mid 2. Okay, then simply I will check in the while loop that is int1 is less than prev1 as well as int2 is less than prev2. If that is, then we will reduce our operation, update our prev1 with index of current element, prev2 with index of mid 2, reduce our mid 1, increase our mid 2, then update our int1 with index of mid 1, update our int2 with index of mid 2, then again iterate for this loop. Okay, and in last I will check that is mid 1 is equal to 0 then break this loop. Okay, because in final we will check for 1 and n, then if again mid one is minus minus, that will be 0, so we don't need to check for that condition. So that is a simple approach, but there are also some edge cases, like if n is odd, then like 9 is given to us, so 1 2 3 4 6 7 8 9, so these will be the pairs for which I have to perform the operation. Then what I written there, that is n by 2 and n plus 2 by 2. Okay, so 9 by 2, that is 4, yeah, that is right. 9 plus 2 by 2, 9 plus 2 by 2, that is not 6. So what I have to do there, for that, can I, 5 is written here, can I say that n plus 1 by 2 and n plus 2 by 2, this is our mid 1 and this is our mid 2, because if n is even, then n by 2 is equal to n plus 1 by 2. So if I update that n by 2 with n plus 1 by 2, okay, if I update that n by 2 with n plus 1 by 2, that is not making any difference if n is even. Okay, but if n is odd, then that will be 5. 9 plus 1 by 2, that is 5, and 9 plus 2 by 2, that is also 5. So that is pointing over middle element. Okay, so if I update over n by 2 with n plus 1 by 2, that is not making any difference on n is, if n is even. Okay, so in this condition what I will do that, like first of all we will check for 5, so we don't need to check anything for this 5. Then 4 and 6, for this I will check that is index of 4 is less than index of 5 and is less than index of 6. If that is, then again we have to go for that while loop, which we check here. Means what is the difference here, that if n is 10, okay, I'm making this is more clear by that. If n is 10, then 1 2 3 4 5 6 7 8 9 10, then we have to check for directly 5 and 6, then 4 and 7, then 3 and 8. There is a simple approach. But if n is even, if n is odd, and that is 9, then 1 2 3 4 6 7 8 9, then we cannot directly check for 4 and 6, because there is also another condition, that is 4 5 6 is index of 4 is less than index of 5 is less than index of 6. If that is, then we can directly jump on that over while loop and start from 4 6, then we'll check for 3 and 7, then we'll check for 2 and 8, then we'll check for 1 and 9. So if n is odd, then we have to check for this condition also. So let's see our code. So first of all, I am taking the input of our array, then this mpp of array of I am updating it with I, that is making index of I is I, oh sorry, index of array of I is I, and that is a 0 based index. Okay, then mid 1 is n plus 1 by 2 and mid 2 is n plus 2 by 2, as I discussed here, that mid 1 is n plus 1 by 2 and mid 2 is n plus 2 by 2. IND1 is index of mid 1, IND2 is index of mid 2. Initially we will perform n by 2 operation, then we will see that is there any chances that we can reduce our operation. Okay, then first of all I will check that is our given permutation is already sorted. If that is, then we will print 0. If that is not, then I will check that is n percent 2 is 1, like what this is checking, that is n is odd. If that is, then we can see that mid 1 will equal to mid 2. Why? As I see here that mid 1 is also 5 and mid 2 is also 5. Then if that is, then I will check that index of mid 1 minus 1 and index of mid 1 plus 1. What is IND1 is pointing out? That is index of 5. Then I am checking that MPP of 4 is less than MPP of 5 and is less than MPP of 6. If that is, then I will decrease our mid 1 with minus 1, increase with mid 2 with plus 1, and update our IND 1 with the index of now 4. This is index of 4 and this is index of 6. Okay, then if that is not satisfied, like if 4 5 6 is not in sorted order, then we have to perform the operation from this step and we will print our initial operation, that is n by 2. And I am continue, so this test case is terminated here, and if that is satisfied, then we will proceed further, that I am storing our current index of mid 1 and mid 2 in pre 1 and pre 2. So on which step we are here, that if n is odd, like this is 10, then here in this condition for mid IND 1, IND 2, mid 1, mid 2. If n is 10, 1 2 3 4 5 6 7 8 9 10. If n is odd, then mid 1 is 5, mid 2 is 6, and IND 1 is index of 5 and IND 2 is index of 6. And if n is odd, okay, so sorry, there is even. If n is odd, like 9, so 1 2 3 4 6 7 8 9. So in this condition, for mid 1 is 4, mid 2 is 6. Why? Because we have updated it in this step. If n is odd, then I am checking first of all that is 4 5 6 is in sorted order. If that is, then I am updating over mid 1 with minus 1. So initially mid 1 and mid 2 both were 5, and if I decreasing mid 1 with minus 1, that is 4, and mid 2 with plus 1, that is 6. Okay, and IND 1 is index of 4 and IND 2 is index of 6. Then I am checking that I am storing over pre 1 with the IND 1 and pre 2 with IND 2. Why I am checking the pre 1 and pre 2? As I discussed there, that I have to update that with our previous index, then IND 1 IND 2, and I am checking that is IND 1 is less than equal to pre 1, pre 2 is less than equal to IND 2, and pre 1 is less than pre 2. Why I am checking this? Because in further steps I don't need to check this, but in the initial step I had to check that is IND 1 is less than IND 2 or not. Why? Because if I want to see that is here, that if 4 and 6 is given to us, then I have to check that is IND 1 is less than IND 4 is less than IND of 6 or not. So for that I am checking this pre 1 and pre 2, and if that is, then I am reducing our operation, and mid 1 is 0, then I am breaking the loop, and in final I am printing the operation. So that was a tricky concept about this problem. I hope you all understand this. See you in the next problem. Till then, happy coding. Bye bye.